So I want to show you here what you're going to see as part of test 4. So you've got question 1 here. What I've done is I've put the reaction types below. I've typed them in so you can go back and look at this for easy access. But obviously you won't see these things typed on the regular test. You can see that on the old tests as well, but they're not typed, whatever type of reaction they are. But here you can see what you're going to get. So for the first question 1, we'll get a Claisen or crossed Claisen. It's going to be one of these kinds of reactions. The other one you'll get is the alpha addition to an asymmetric ketone, which could involve, like this, ET3N and heat, or VLDA at minus 78 degrees. The 1,4 addition could be one that involves an organolithium like this one, or one that involves an organocopper lithium. You'll definitely get an Siluan condensation. You'll get a 2D Diels-Alder reaction that involves an acyclic diene. So what I mean by that is that this diene here, the double bonds are not linked together, so that's acyclic. That's going to require a 2D diagram, which needs to show stereochemistry, by the way. And the other type is this 3D Diels-Alder that has a cyclic diene, and as you can see, the diene is tied together, is linked by two more things here. I'm not talking about this part here being cyclic, I'm talking about this part here joining together on the diene part, and that's going to require a 3D diagram. The next thing you get is an aldol or crossed aldol condensation. This one here happens to be a crossed aldol condensation. Over here we've got the enamine assisted alkyl addition. You'll get one of those as well. You'll get a Novnagel condensation. You'll get a Michael reaction. Down here you're going to have some sort of problem that involves a diene competition reaction, and you'll be required to come up with an energy diagram that explains the distribution of these products. Question 3 will be a mechanism problem, which will either be an aldol, a crossed aldol, a Claisen, or a crossed Claisen. This one here happens to be a crossed aldol reaction. This one here will be the malonic ester or acetoacetic ester synthesis. So those are the two possibilities here. If you go back and look through the notes, you'll see if we start off with a carboxylic acid like we have here, we'll be using the malonic ester. If we start off with a methyl ketone, then we'll be using the acetoacetic ester synthesis. This hasn't paginated properly. Number 5 is going to be a roadmap problem, but here it is down here. Let me see if I can remove some of this other stuff. Page it back a bit. There we go. So you can see here that what you'll get is something that involves a Dieckmann condensation, which is going to be a cyclization process. And then you'll see that it's basically the acetoacetic ester synthesis after that to come up with these products here. And I would encourage you to look at both the PowerPoint notes and the videos that go through this to see how to do that kind of problem. The last one here, let me just page this back up, is a synthesis problem that involves the aldol or the Claisen reaction. It could be aldol, crossed aldol, Claisen, or cross Claisen. And your mission here is to come up with the reagents that would end up giving these products here. But again, I would encourage you to look at the videos for those.